All right, welcome to your personalized TypeScript interview deep dive.
Yeah, this is exciting.
We've got a ton of these common interview questions that you gave us.
Yeah,
But we're not going to just go question by question.
right.
We're going to kind of take a helicopter ride to the top of this mountain of questions and look at the core TypeScript concepts.
Okay.
So you can answer anything they throw at you.
Right.
Not just by memorizing answers, but by deeply understanding the why of TypeScript.
It's like instead of just looking at the finished building,
Yeah,
you have the blueprint to build the skyscraper.
exactly.
Yeah.
So let's just start with the very foundation.
Okay.
What is TypeScript
Okay.
and what problem does it solve?
So TypeScript is it's basically JavaScript with superpowers.
Okay.
It's a superset of JavaScript, meaning it includes everything JavaScript has,
Mhm.
and then it adds this really powerful feature, static typing.
Right.
So with JavaScript, you don't know what type of data a variable holds until the code actually runs, which can lead to all kinds of unexpected errors.
Right. So it's like driving a car without brakes and just hoping you don't hit anything.
That's a very vivid way to put it, yeah.
Yeah.
So TypeScript brings the brakes.
Yeah.
With static typing, you declare the type of data a variable will hold up front.
Okay.
So think of it this way.
Yeah.
You're telling the code, this variable, it will always be a number,
Mm-hmm.
and if you try to put anything else in it, I want you to yell at me right now.
So it's like a spell checker for your code.
Mhm.
It catches the errors before they become bugs.
Exactly. And not only does it catch potential errors,
Right.
it also acts as living documentation within your code,
Oh, okay.
making it easier for you and your team to understand what's going on.
Mm-hmm.
Now, it doesn't mean that TypeScript changes how your code runs in the browser.
Okay.
It actually compiles down to plain JavaScript that the browser can understand.
That makes sense.
Yeah,
It's like having the blueprint to guide the construction, but the final building still stands on its own.
right. Now, let's talk about some of the key tools that TypeScript offers to bring structure and maintainability to your JavaScript code.
Okay.
One of the most important is interfaces.
Okay. So I've seen these in a lot of the interview questions,
Mm-hmm.
but I'm still not 100% clear on what they do.
Okay, so think of interfaces as contracts for your code.
Okay.
Let's take a real-world example from the material you provided.
Mm-hmm.
You have an interface called animal
Okay.
with a property name of type string.
Mm-hmm.
This means that any object that implements the animal interface must have a name property,
Okay.
and that property must be a string.
So it's like saying, if you want to be in the animal club, you got to have a name.
Yes.
And it better be a real name, not like a number or something weird.
That's the spirit.
Yeah.
And why is this important? Imagine
know.
you're building like a zoo simulation.
Yeah.
You have all these different types of animals, each with specific behaviors. Interfaces make sure that, if you're dealing with an animal, it will have the expected properties, like a name.
Right. Right.
This prevents you from accidentally, trying to feed a number to a lion, expecting it to be its name.
Makes sense.
Yeah.
So it's all about making sure everybody plays by the rules
Right.
and avoids those silly mistakes that lead to hours of debugging.
Exactly. Now, let's shift gears to another powerful tool, classes.
Okay.
So while interfaces define the structure, classes are actually the blueprints for creating objects.
Mm-hmm.
They can have properties, methods, and even implement interfaces.
So if the interface is the blueprint for a house,
Yeah,
the class is the actual construction crew that builds it.
that's a great way to visualize it.
Okay.
Yeah, classes give you this structured way to organize your code and create reusable components.
Okay.
For instance, in your zoo simulation, you might have a lion class that implements that animal interface.
Okay.
And this lion class would have properties like name, age,
Mhm.
and methods like roar.
This makes the code a lot more readable and organized, right?
Precisely.
Yeah.
And speaking of keeping things organized and reusable, let's move on to generics.
Okay.
They're like the Swiss Army knives of TypeScript,
Okay.
allowing you to write code that can work with any type while maintaining type safety.
I've seen some examples using that T syntax.
Yes.
It looks a little like alien language to me.
Yeah.
But I'm ready to decode it.
You and me both.
Okay.
So let's say you want to write a function that simply takes a value and returns that same value.
Okay.
Now, in JavaScript, you could do that easily, but you wouldn't have any control over the type of data going in and out.
Mm-hmm.
Now, with TypeScript, you can use generics to define a function that can work with any type.
Okay.
Still ensures that type safety.
So it's like having this magic box that
Mhm.
can hold anything,
Yeah.
But it also comes with a label
Yeah.
that tells you exactly what's inside.
You got it.
Okay.
One of the examples you provided is the identity function. It uses this T syntax to represent any type.
Okay.
And this function, it takes a value of type T and returns a value of the same type. So you can use it with numbers, strings, or even complex objects.
Okay.
And TypeScript will ensure that the output type always matches the input type.
That's pretty neat.
Yeah.
So it's both flexible and predictable.
Absolutely. And this brings us to another essential concept, modules.
Okay.
So in a large project, you don't want to have all your code crammed into a single file.
It'd be like finding a needle in a haystack.
Exactly.
Yeah.
So modules allow you to break down your code into smaller, manageable pieces,
Okay.
each with its own specific purpose. This makes your code easier to understand, maintain, and test.
Okay.
You can export specific parts of your code from a module and then import them into other modules as needed.
So if our zoo simulation is getting really big,
Yes.
we can have separate modules for the different animal types and enclosures.
That's right.
And like visitor management.
Exactly. So modules are like different departments in a company,
Okay.
each responsible for its own area of expertise.
Right.
And by keeping things neatly organized, you avoid naming conflicts and make your code base much easier to navigate.
I'm starting to see how all these pieces fit together.
Good.
But I know there's some specific keywords in TypeScript that could be a bit confusing.
Okay.
Maybe we can demystify a few of those.
Absolutely. Which ones are you curious about?
Well, I see public, private, and protected popping up a lot in the class definitions.
Yeah.
What's the deal with those?
Think of it like building a house again.
Okay.
Public members are like the front yard.
Okay.
Everyone can see them and access them. Private members are like your bedroom.
Okay.
Only you have access.
Okay.
And protected members are like a shared family room.
Okay.
Accessible to family members, the class itself, and any subclasses.
Okay.
But not to outsiders.
So public is the most open.
Yeah.
Private is the most restricted.
Right.
And protected is somewhere in between.
Exactly.
It's all about like controlling who has access to different parts of your code.
Precisely. And these access modifiers are crucial for building well-encapsulated and maintainable code.
Okay.
They help you prevent accidental modifications and ensure that different parts of your code interact in a predictable way.
Okay, this is starting to make sense.
Good.
But before I move on, I'm curious about this any keyword I keep seeing.
Oh, yeah.
Is it like some kind of magic wild card?
Any is it's a bit of a double-edged sword.
Okay.
It essentially tells TypeScript, hey, I don't know what type this is.
Okay.
So just trust me.
Okay.
And it can be tempting to use any when you're dealing with complex data or external libraries.
Sounds like the easy way out.
In a way, yes.
Yeah.
But here's the catch.
What?
By using any, you're basically bypassing all the benefits of TypeScript's type safety.
Oh, okay.
It's like wearing a seatbelt but then cutting the brake lines. Or taking on unnecessary risks.
Yikes. I'd rather not do that.
Yeah.
So what's the alternative?
That's where unknown comes in.
Okay.
It's like saying, I don't know the exact type, but I'm going to be responsible and figure it out before I do anything with it. Unknown forces you to perform a type check before you can use the value.
So it's like wearing a safety harness while rock climbing.
Yes.
You're still taking risks, but you're doing it safely.
That's a great analogy.
Okay.
Unknown encourages you to be more mindful and deliberate about how you handle potentially ambiguous data.
Okay, this is all incredibly useful.
Yeah.
But I'm also wondering, is there a way to express that something should never happen?
Oh.
Like a function that never returns.
You're thinking about the never type.
Okay.
Imagine a function that always throws an error.
Okay.
Or gets stuck in an infinite loop.
Right.
In these cases, the function will never actually return a value.
Okay.
The never type is used to represent these scenarios where a value should never occur.
So it's like that elusive unicorn sighting in my backyard.
Yeah.
It's never going to happen.
Exactly. Never helps you express those exceptional cases where your code shouldn't reach a certain point.
Oh.
It adds another layer of precision to your type system.
Wow, we've covered a lot of ground here.
We have.
It's like we've built this solid foundation for our TypeScript skyscraper.
Yeah.
But before we start adding floors, I want to make sure we understand why these concepts are so important.
That's a fantastic question.
How do they connect back to writing better code?
That's a question we'll explore further in the next part of our deep dive.
Okay.
We'll shift our focus from the what to the why. examining how each of these concepts helps you tackle real-world development challenges.
I'm excited to delve deeper into that.
Me too.
Yeah.
So let's shift gears a bit and explore the why behind these TypeScript features.
Okay.
We've laid the groundwork.
Yeah.
Now let's see how these tools actually help us solve real-world coding problems.
Okay, I'm all ears, especially when it comes to, making my code less buggy and easier to maintain.
Absolutely. So let's start with interfaces.
Okay.
Imagine you're working on this large project
Mm.
with like a whole team of developers,
Right.
and you're all building different parts of this application,
Yeah.
but those parts need to communicate with each other seamlessly.
Right.
Interfaces act as a shared language, ensuring that everyone agrees on the shape and structure of the data being passed around.
Oh, okay. So it's like having a universal translator for our code,
Yes.
preventing those like miscommunication and those. But I thought it was supposed to be a number moments.
Precisely. Interfaces help you avoid those integration headaches and ensure that different parts of your code work together harmoniously.
Okay.
Now let's talk about generics.
Okay.
Remember that magic box we talked about earlier?
The one that can hold anything, but also tells you exactly what's inside.
Exactly. So generics are all about writing reusable and flexible code. Imagine you need to write a function that sorts an array.
Okay.
In plain JavaScript, you might end up writing separate functions for numbers, strings, and other data types.
Right. Right.
But with generics, you can write a single sorting function
Okay.
that adapts to any type
Okay.
while still ensuring that type's safety.
So it's like having a single sorting algorithm
Yeah,
that can handle any kind of data, from books on a shelf to contacts in your phone.
that's a great way to visualize it.
Yeah.
Generics eliminate code duplication and make your code more concise and maintainable.
Okay.
And speaking of maintainability,
Yeah.
let's not forget about modules.
Right.
As your project grows, it's crucial to keep your code base organized and prevent it from becoming a tangled mess.
Nobody wants to deal with a code jungle.
Right.
Yeah.
Modules allow you to break down your code into smaller, self-contained units,
Okay.
each focused on a specific functionality.
Oh, okay.
Think of them as the different chapters in a book, each telling a part of the story while contributing to the overall narrative.
So instead of having one giant script that does everything,
Yeah,
we can have separate modules for like user authentication, data fetching,
that's right.
UI components, and so on.
Exactly. This modular approach makes your code easier to understand, test, and debug.
Okay.
It also promotes code reuse and collaboration within a team.
Makes sense.
Now, let's shift our focus to error handling.
Okay, this is a big one.
It is.
In JavaScript, error handling often feels like an afterthought.
Yeah,
But TypeScript seems to have a more proactive approach, right?
absolutely. Remember how we talked about TypeScript catching errors early on with static typing?
Yeah.
Well, it takes that a step further by encouraging you to think about potential problems and how to handle them gracefully.
So instead of just like hoping for the best,
Yeah.
we're actively planning for things that could go wrong.
Exactly. And one of the key tools for this is the try.catch statement. It allows you to isolate code that might throw an error and define specific actions to take if an error actually occurs.
So it's like having a safety net under a trapeze act.
Yes.
Even if the performer makes a mistake, there's a system in place to catch them.
That's a perfect analogy.
Yeah.
Now, what makes TypeScript's try.catch even more powerful is the ability to specify the type of error you're expecting to catch.
Oh, okay. So instead of just catching any error, we can target specific types of errors like network errors, database errors, or even custom errors that we define ourselves.
Precisely, this granular approach to error handling makes your code more robust and predictable.
Okay.
You're not just blindly catching everything, you're handling different types of errors in a way that makes sense for your application.
Okay. I'm seeing the value in planning for failure.
Good.
It seems counterintuitive, but it actually makes your code more reliable and easier to maintain.
Absolutely. Now let's talk about some of those more advanced types we mentioned earlier. Unions and intersections can be incredibly powerful tools for modeling complex data structures and relationships.
I remember the basic idea,
Yeah.
but maybe you can give me a real-world example of how these are used in practice.
So imagine you're building an e-commerce platform.
Okay.
You have a product type, but some products are physical goods that need to be shipped,
Right.
while others are digital downloads.
So like a physical product would have properties like weight and dimensions.
Yes.
And a digital product would have a download link, for example.
You got it. With union types, you can define a product type that can be either a physical product or a digital product. This allows you to model the different variations of a product
Right.
while still maintaining type safety.
So it's like having a single category for products, but then having subcategories for different types of products.
Exactly.
Keeps things organized, but also allows for flexibility.
Exactly. And intersections allow you to combine multiple types into a single type. Let's say you have an interface for a user and another for an admin.
Right.
You can create an intersection type
Okay.
that represents an admin user who has all the properties and methods of both a user and an admin.
So it's like taking the best of both worlds.
Precisely. These advanced types allow you to create more expressive and accurate representations of your data.
Okay.
Now, are you ready to dive into a topic that often trips people up in interviews?
Oh, boy.
The interaction between TypeScript's type system and JavaScript's prototypal inheritance model.
I have to admit, this one sounds a bit intimidating.
Yeah.
But let's face our fears and unravel this mystery. Okay, we're back for the final part of our TypeScript deep dive, and we're tackling a topic that's,
Yes.
well, it's fascinating, but it could be a little brain-twisting.
It can be.
This whole interplay between TypeScript's type system and JavaScript's prototypal inheritance.
It's like we're exploring two sides of the same coin. You know, on one side, you've got TypeScript's world with these static types where everything's really neatly defined and checked at compile time.
Right.
And then on the other side, you have JavaScript's dynamic world of prototypes, where objects can inherit properties and behavior from their ancestors in this like more fluid runtime-based way.
Okay, my head's already starting to spin, but I'm with you. Let's break this down. First, can you just remind me what prototypal inheritance is all about?
Sure.
It's been a while since I brushed up on my JavaScript.
At its core, prototypal inheritance is this mechanism where objects can inherit properties and methods from other objects. They're prototypes. Think of it like a family tree, where objects are inheriting traits from their parents, grandparents, and so on.
Okay, so instead of classes that define blueprints for objects, JavaScript uses this chain of prototypes to pass down those characteristics.
Exactly. When you access a property or a method on an object, JavaScript first checks if the object itself has that property or method. If not, it goes up the prototype chain. It looks for it in the object's prototype, then the prototype's prototype, and so on.
So it's like searching for a family heirloom.
Yes.
You start in your own attic, and if you don't find it, you go check your parents, then your grandparents, until you find it.
That's a great analogy.
Yeah.
Now, here's where it gets really interesting with TypeScript. TypeScript understands this whole prototypal inheritance model. But it layers on top of it its own static type system.
So it's like TypeScript is adding this detailed map to our family tree.
Yes.
With labels and annotations that help us navigate it.
Precisely. TypeScript allows you to define types for your objects and their prototypes. Which gives you much stronger guarantees about how your code's going to behave at runtime.
So even though objects are inheriting those properties and methods dynamically through these prototypes, TypeScript is still there, making sure everything is type safe and predictable.
Exactly. TypeScript's type system works in harmony with JavaScript's inheritance model to give you the best of both worlds. The flexibility and dynamism of JavaScript, but also the safety and structure of static typing.
Okay, I think I'm starting to see the bigger picture here.
No?
But are there any practical implications of this interplay, between types and prototypes?
That's a great question.
Are there any situations where they might clash or cause confusion?
Yes, there are some nuances to be aware of.
Okay.
For example, when you're working with classes in TypeScript, you're essentially defining both a type and a prototype.
Okay.
So the class itself acts as a constructor function, while the type represents the structure of the objects created from that class.
So it's like having two blueprints, one for building the factory and then one for building the product.
Exactly. And sometimes this duality can lead to some subtle behaviors that might catch you off guard. For instance, if you modify the prototype of a class at runtime, those changes won't be reflected in TypeScript's type checking because the type was already determined at compile time.
So it's like making changes to the factory after the product's been shipped?
Yes.
The product's not going to like magically update itself.
Right. It highlights the importance of understanding both the runtime behavior of prototypes
Hmm.
and the compile time checks of TypeScript.
Okay, I'm definitely feeling more enlightened about this whole, complex dance between types and prototypes.
Good.
Before we wrap up,
Yeah?
anything else we should keep in mind when it comes to TypeScript interview prep?
One thing that often impresses interviewers is
Okay.
demonstrating a good grasp of TypeScript's design goals.
Oh, that's interesting. What are some of those goals?
A key goal is to improve code quality and maintainability
Okay.
by catching errors early on and making code easier to understand and refactor.
Mm-hmm.
Another goal is to enhance developer productivity by providing better tooling and a more structured way of working with JavaScript.
So TypeScript isn't just about adding types.
Right.
It's about fundamentally improving that whole JavaScript development experience.
Exactly. And if you can convey that understanding in an interview,
Yeah.
it shows that you're not just, learning the syntax.
Right.
You're actually grasping the deeper motivations behind the language.
That's a great point. It's not just about what TypeScript does,
Yeah,
but also why it does it.
exactly. And one final thought to leave you with.
Okay.
TypeScript is a constantly evolving language.
Right.
New features and improvements are being added all the time. So it's
Wow.
important to stay curious and keep learning.
Great advice. So to recap, we explored TypeScript's core concepts,
Mm-hmm.
types, interfaces, classes, generics, modules, and more.
Mm-hmm.
We decoded some of those confusing keywords, tackled error handling, delved into advanced types,
We did.
and we even unraveled the mysteries of types and prototypes.
You've covered a lot of ground.
And I feel a lot more confident about actually using TypeScript in my projects.
Good.
So thank you for being such a fantastic guide.
You're very welcome. Remember, the best way to master TypeScript is to actually use it.
Okay.
So keep experimenting, keep exploring, and just keep pushing the boundaries of what you can build with it.
Awesome. Well, to our listener,
Yes.
we hope this deep dive has given you the knowledge and confidence to not only conquer that TypeScript interview,
Yes.
but to embrace this really powerful language as a tool in your coding journey.
Happy coding.
Until next time, keep diving deep.